All right. Welcome, everyone. Good morning or good afternoon, wherever you may be. My name is Daniel Moyer. I'm one of the sales support trainers here at Simplify Power Briggs & Stratton. What I got for you today is our Battery 101 chemistry talk. Couple housekeeping items before we begin. This is a NABCEP accredited course. So if you're looking for your continuing education credits, wait till the end of the talk. There'll be my email is going to pop up and we'll be able to email me your full name, spell it out for me so I get it correct on your certificate. So if you're looking for your continuing education credits, this is an accredited course. At the end of this presentation, my email is going to pop up. Go ahead and email me and I'll go ahead and get you over your credits. If you have any questions during the talk, we don't have the ability to raise your hand or anything like that. Go ahead and put your questions into the Q&A chat. There's a button either at the top or the bottom that says Q&A, and we'll go ahead and address your questions either during the talk or at the end of the talk when we have some time for questions. Again, I'm really excited to have this be part of NABCEP. We are working on some newer trainings coming up this year. Stay tuned for some of those. In fact, we do have another new training coming up next week that Nathan Heston is going to be giving. So we'll go ahead and take a look at that here at the end of this talk. So again, Daniel Moyer, Briggs & Stratton, Simplify Power. Couple of training opportunities before we begin. One is that with the acquisition of Briggs & Stratton to Simplify Power, we can now leverage the Power Academy. The Power Academy is this really powerful online learning portal that has virtual trainings, self-paced trainings, and even ability to sign up for live in-person trainings. So take a look at that. We're going to jump in a little bit of how to register for that at the end. Always keep an eye on our training calendar on the Simplify Power website. That's where you can see this exact opportunity, how you found me today. There's upcoming trainings, and we'll take a look at some of those newer trainings coming up. So we're going to get quickly through some of the history of Simplify Power Briggs & Stratton, talk a little bit about some of our products, and then jump right into Battery Chemistry 101. Simplify Power was founded back in 2010. Our original product to market was a lithium iron phosphate battery. So at that time, which is kind of ancient history in the whole realm of things for batteries, was a safer battery founded on safety. And then we ultimately kind of started in the film and broadcast industry. We actually assemble these batteries in Oxnard, California, which is near Southern California, just north of Los Angeles. So when we started assembling these batteries, we found a market in the film and broadcast industry, right? Hollywood. And a lot of times they needed these portable, safe power packs to help film TVs or movie shows. In 2011, 2012, we really had an opportunity to take what we have been using these batteries in the film industry and then have them proven by the military. The Army had at that time really been using diesel generators to run some of these forward operating bases, and also been using lead acid batteries, and they really weren't being successful. Those batteries and generators weren't filling the mission that they needed. We approached them with lithium iron phosphate, lithium-ion battery, and they kind of paused and said, wait a minute, we hear that at that time there was a lot of bad news around these lithium-ion batteries. And we said, look, we have a safer chemistry, we have a safer form factor, give us a try. And they did. They took our batteries out to the Aberdeen Proving Grounds, which is out in Maryland, put these batteries through some very high temperature, high vibration environments, and we were successful. They liked what they saw, and we ultimately did deploy. 2013, 2014, we had an opportunity to start kind of expand our product line into the residential market. 2015, 2016, we relaunched as Simplify Power. And that was, if you think about it, right when the first Tesla Powerwall came into the market, wasn't until the mid-teens. So if our industry, right, the idea that we could put grid interactive energy storage systems onto homes isn't that old of an idea. It's relatively new. And so that's what's exciting, is that we were one of the founding kind of people into this market. And we've been around long enough to actually have batteries outliving our warranties. So it was really cool to see us kind of be one of the first people into the market. Go into a trade show today, I'm just blown away by the number of different options. So I was really excited to see that we've been somebody with a lot of history in this market, and somebody has proven technology in this market. 2017, 2020, we began ramping up manufacturing. We opened up a research and development facility next to the factory in Oxnard. Again, we actually assemble these batteries in the United States, but having that research and development facility has allowed us to kind of stay at the leading edge of some of this technology, make sure what we're providing to you, to your homeowners, is something that's safe and proven. What's really exciting recently is with the acquisition, Briggs & Stratton bought Simplify Power. And by that, having that acquisition, we're able to leverage a company that's been around for over 100 years, Briggs & Stratton, with a history of providing power producing equipment to the homeowners in the United States. So with that, they got a lot of deep pockets for us to see for the future product development, and also really leverage their name, their brand name recognition. So when we are sitting down at a kitchen table with homeowners, they recognize that brand name, and they're excited to be part of that industry. Nathan, are you on the line with us today? All right, I think Nathan still might be muted.
Yeah, I'm muted. Sorry about that, Daniel. Yes, thank you.
Yeah, Nathan, just thank you for joining us today. I want to introduce everybody. Nathan Heston, he's one of another sales support trainer here. Nathan, I talked a little bit earlier about some upcoming trainings. Is it true we have a new training coming up? And can you tell us a little bit about it?
Yeah, sure. We have a new training coming up next week, which will be the first time we're launching this training, which is going to talk about how to optimize solar power generation, so solar energy production, by using batteries. And I'm looking forward to delivering that one next Thursday. And so please stay tuned. And if you get a chance, sign up.
Yeah, great. And again, I showed it just another slide ago. You go to simplifypower.com, go to our training calendar, and that's how you're going to find the link to get to Nathan's talk coming up. One thing I'm really excited about the Briggs & Stratton is that now we can be experts in both home power standby generators. You're seeing it on our picture right there. These are either propane or natural gas standby generators. And as somebody who comes from kind of the off-grid industry, I worked at Sunfrost, which is a DC refrigeration company. And coming from the off-grid solar world, generators and solar have always been complementing each other for a long time in off-grid situations. Why? Because if you're off-grid, you don't have a grid. So in the wintertime, you're not getting as much sun. You have to be able to charge up those batteries and get you through the dark days of winter. Otherwise, I'd have to oversize your solar system, to be way oversized in summer to get you through winter. So now that we're experts in both, and I'm also working on a new training. It's going to be coming up later next month about how generators and energy storage systems can complement each other. So you're seeing a 10 kilowatt generator on the left there, and then on the right, you're seeing one of our 26K generators, either natural gas or propane. Up top, you're seeing our vertically integrated energy storage system. And we're going to talk a little bit more about that later. But really, to have that US-based manufacturing, we have tech support and training teams that are experts on both generators and on energy storage systems, and really the deep pockets to commit to some of those future technical innovations. One thing I do want to talk a little bit about is how we've seen such a big growth in our commercial industry. So we're going to talk a little bit about high voltage batteries here in just a little bit. So we all know the drivers. Home is the haven. A lot of people are working from home, learning from home, and we see a lot of people that want to have that grid independence. That kind of came out of the COVID industry. We've also seen that existing infrastructure really isn't being kept up the way it should. We see this with people's power going out. Old transformers that are up on the power poles really weren't designed for the electrification of everything demands that we're putting on the grid. Climate-related disasters, here in California, we had those planned power safety shutoffs where during high wind events, power lines would be swaying in the wind and they would arc against trees, causing forest fires, which led to some really disastrous fires that burnt down whole communities. Paradise, California, for example. What is PG&E doing about it? Pacific Gas and Electric, my utility, they're shutting down the power grid preemptively under the guise of being safety. Well, there's nothing safe about shutting off power to millions of people. So we can see that they're trying to bury the power lines now, but we're not seeing that move quite as quickly. Ice storms in Texas, hurricanes down in the south, other events. So we understand that these climate-related disasters, not investing in our grid, and people really needing that independence, that resiliency, is leading to this kind of increased demand, right? So we see a lot of people who got solar, maybe they have solar already, and they didn't do storage, now they want to add storage. Well, that's what's great about these energy storage systems, is that we can come in and AC couple in onto an existing solar array. Don't got to get up on the roof. Don't even get the ladder off the truck. Let's go ahead and AC couple in an existing energy storage system to AC couple onto an existing solar system. One thing that is kind of interesting that's been a big market driver is here in California. Recently, we went from net metering 2.0 to a new net metering paradigm, net metering 3.0. And what that kind of means in a nutshell is, historically, when you were in California and you produced excess energy, you could send it back out to the grid. You'd get a credit for it, a one-for-one credit. In the summer, during the daytime, you could produce those credits. In the winter, at nighttime, you could use those credits up. And then at the end of the year, or on the anniversary of the installation of your system, you'd get a true-up bill. And ideally, you wouldn't owe your utility anything, they wouldn't owe you anything, and maybe you're paying $10 a month just to be connected to the grid. Well, what's happening with these new net metering agreements, and it's not just in California, it's starting to happen on other parts of the country, is that instead of you getting a one-for-one credit, it's for every unit of electricity you send back to the grid, you get a fraction of the credit. And when you consume electricity, you're still paying that full credit. So if you produce it and you don't use it, you lose it. So what do you got to do? You got to store it. So I think we're seeing that net metering changes really going to start to be a market driver for these home energy storage systems. And there's reasons why they're doing this. One is that we're just getting so much solar connected to the grid that during the daytime, the price of electricity is almost going negative in some examples. So another market driver is really the new ITC, the ability to have a 30% tax credit. Historically, it only been allowed to be on a solar and storage together. You couldn't take it with just storage. Well, that's now changed. Now we can leverage a 30% tax credit on the storage only. So you can come into somebody's house, maybe they don't have solar. Let's go ahead and still leverage that 30% tax credit. Maybe they want storage and a generator. Well, they can then leverage that 30% tax credit on the storage. Again, it's decoupled it from the solar component of it. And that's going to go all the way through. My slide's out of date there. It should say 2033. The end use applications are numerous. Upgrading of an existing solar homes. I just talked about that. Somebody's got solar who wants to add storage. Time of use arbitrage, right? During certain times of the day, power is more expensive. Well, like 4 to 9, usually in the evenings, we can tell the energy storage system, go ahead and discharge yourself during those high price times and cover the home's loads. Net metering 3.0, just talked about that. With those new solar storage incentives, that's really going to be hitting that with the homeowners. Selling power back to the grid. Solar ready new homes, that's not too common in most parts of the country, but it's starting to pop up here in California where I'm located. What is a solar ready new home? Well, it's maybe a home that has a 225 rated amp bus bar with a 200 amp main. It's allowing you to backfeed a lot more solar onto that bus bar without exceeding the ampacity. Maybe it has conduit that's already running up to the attic crawl space, so you can go ahead and add solar without having to run, conduit on the outside of the home. Off-grid has been a big part of our industry, and we're a company that still continues to offer batteries that make great lead acid battery replacements. Replacing existing energy storage systems, that's not too common right now, but I see that kind of becoming more common. And eliminating peak demand rates, similar to time of use, but that's if any time during the day your power consumption in kilowatts exceeds a certain threshold, we can program the energy storage system to cover and shave those peaks off. Demand management, which is another kind of utility controlled program that's being offered, where essentially you allow an utility company, it's usually more of a local energy co-op, to take control of your energy storage system and let them discharge it when they see that it's going to be beneficial to the grid. They financially compensate you for just being part of that program, and they also financially compensate you for some of those for every kilowatt hour you put back out onto the grid. So if anybody I'd love to see that in the chat. If anybody is part of one of those programs or lives in a part of a community that's participating in that, please put it in the chat. Let's have a little deeper conversation about that. One thing I mentioned at the beginning, we've always been known for our safe technology. We use lithium iron phosphate batteries, which are cobalt-free. Being cobalt-free, we don't have that risk of unmitigated thermal runaway with fire propagation. You can still have a thermal runaway with one of our battery cells, but what happens after it goes into thermal runaway? Does it continue to spread from battery to battery, or does it kind of just put itself out? A little bit later in this talk, we're going to talk about the 9540, 9540A UL listings that kind of dive a little bit deeper and really prove just exactly how safe some of these battery chemistries and battery form factors matter. UL 1642 is on the cell level, and UL 1973 is on the battery module level. We do have permission from the Department of Transportation to airship our batteries. That's UN DOT 38.3. And we also have 3480, which allows us to LTL freight ship these batteries to you. So think of FedEx Freight and those other kind of LTL shippers. We are one of the few companies that's been around longer than our warranty length, right? So what I mean by that is we have a 10-year warranty on our batteries, and we've been making batteries for longer than 10 years. So we do actually indeed have batteries outliving their warranty out in the field. And I can't say the same for a lot of our other competition. A lot of these other companies have just popped up in the last year or two, and they really haven't proven themselves like we have by deploying all around the world and over 300 megawatt hours. We've been tested and validated by the US Army and the Marine Corps. I talked about that with the Army at the Aberdeen Proving Ground, but also we worked a little bit with the Marine Corps at some of their forward operating bases. We do have a business model that can demonstrate social impact and profitability can coexist. It's the so-called triple bottom line: people, planet, and profits. And we do truly give back, usually in the form of batteries. So if you have a project that you have in your mind, email us. My email is going to pop up at the very end of this talk, so you can claim your NABCEP credits, but also email us your idea. We've worked with schools, all sorts of different clinics, hospitals, usually in developing countries, but also here in the United States. Nathan, is there anything you wanted to add on some of these projects that we've done around the world?
Well, we just had a school come online in rural Peru at high altitude. This was an insulated battery installation. We've done a number of installs in Native American communities. And there are a lot of great projects, and we want to hear from you the projects that you have in mind as well. So send us an email if you've got a nonprofit in mind that might benefit from putting in an application and potentially getting some batteries.
Absolutely. Simple. So it's in our name, right? Simplify. We've always made a battery, and we're going to look at the different battery types we have. You can see some down there on the bottom left there. We've made a battery that's easy to integrate into existing systems. So if you have one of those systems, like an off-grid system that has lead acid batteries, like some old Trojans or MK Deca batteries, we can go ahead and swap those batteries out for our lithium-ion batteries. All you got to do is get in there to your MagnaSign, to your Schneiders, to your Victrons, adjust the set points in that piece of equipment, whether it's a charge controller or an inverter, to treat our batteries correctly, right? So it's usually adjusting the float voltage, disabling and equalize, adjusting the bulk, setting that low battery cutout voltage, usually a little bit higher than what we'd see on some lead acid batteries. The point being here is that we can integrate into existing systems, give that critical backup power, maximize the resilience and the energy security to help them start creating savings. So I quickly run down the bottom. Those are our batteries. Those are our workhorses. The Phi 3.8, so 3.8 kilowatt hour batteries. What you're seeing under integrated systems is our Boss cabinets. This is a NEMA 3R rated outdoor cabinet that you can put up to 12 of our batteries into. We actually can also put an inverter up there. We're going to look at that here in a second. We have our vertically integrated energy storage system right there under Simplified ESS. So historically, and we still do this, Simplified Power makes a battery that's inverter agnostic. You can use our battery with almost anybody other's pieces of equipment that allows other batteries to be used on, as long as you program it correctly. The way the market's going, though, is everybody's kind of doing this vertically integrated energy storage system, which is exactly what we came out with. It's one warranty, one tech support call, and it's one app. We're going to talk a little bit about that a little later here. High voltage solutions, I don't want to be remiss because it's been a huge growth in that industry. I'm thinking of the SolArc 30K. I'm thinking of the SolArc 60K. These small three-phase 208 inverters that can be leveraged in small commercial and light industrial, keep businesses going. These high voltage battery solutions we have are perfect for that pairing. We talked a little bit about these UL listings, jump a little bit deeper into that. 1642 is on the cell level, 1973 on the battery module, 9540 on the system level. And then how 9540A comes into play, it's actually a large-scale fire test. And we take one of our energy storage systems, we send it to a UL lab, and it's not just UL lab now doing these 9540A tests, but they're kind of the big name here. They force some of these cells into thermal runaway, and then they watch what happens. And kind of a spoiler on what happened with us is not much happened. And by having a system that didn't have much happen, we're able to then call out in our 9540 UL listing certain separation distances. It helps accelerate some permitting processes. It also really helps if you ever have any insurance purposes. Let's say you're off grid. I'm not having it inspected. Why does it still matter for you? Well, it's that peace of mind knowing that you have something that's UL listed. And if you did ever need to sell the property, sometimes people are going to be looking for that. I'm not really seeing, I know in my jurisdictions, we do have inspectors that are up to speed on this, and they are looking for those UL listings, and they're not going to let you pull a permit unless you are installing equipment that has these UL listings. Fortunately, what I'm seeing in the industry is a lot of people are moving towards having these listings that are coming to market. Talked about this already. Just kind of give you a visualization of what it looks like. Peak shaving, right? We can shave those peaks off, and that can be significant savings for some of our commercial users. Time of use rates, again, we can discharge the battery during those high peaks, saving the homeowner from having to buy expensive power from the grid. And with that new net metering paradigm, we can generate solar, store that solar clean energy in our batteries, and then discharge it at night. We have a bunch of different chemistries on here. And I might let Nathan here talk a little bit about kind of the fundamentals and really break it down. Why is cobalt such a dangerous element when it comes to having it in an energy storage battery. Nathan?
Hey, Daniel, thanks for giving me the opportunity here. So there are a number of different types of batteries that are listed here, and all of these different types of batteries differ in the material that is used for the positive side of the battery, what's typically referred to as the cathode side. For putting cobalt into the cathode side and using something like nickel manganese cobalt oxide or lithium manganese oxide batteries, with those also often include cobalt, or NCA-LCO, allows for a lighter battery for the same amount of energy being held. So there's some advantages in doing that. The downside to that, though, is that it makes the batteries much more prone to fire. And that has to do with the chemical reaction that occurs on the positive terminal of the battery when that lithium is being migrated. So when you're charging and discharging. And you end up having a slightly higher voltage with those batteries, and therefore you have some more energy. But that higher voltage also results in those batteries being more prone to fire. So there are two reasons. One, they all include oxygen in the cathode material itself, and they have a higher voltage. And so if a chemical reaction happens in which burning begins, it's really hard to get these other batteries out. Now, don't get me wrong, I think the NMC batteries, which you'll typically find in your power tools, they're great. You don't want a 20-pound drill. But if you're looking to just back up your house or your cabin, you don't care if that battery is 25% heavier. We use iron instead of cobalt for our cathodes. So that's what the lithium ferrophosphate, ferro means iron. And so our batteries are a little bit heavier, but they're longer lived. So they last longer, you get more cycles out of them. And the biggest thing, of course, when you're gonna put something on your home is they're safe, much safer, right? So even when fires start with LFP batteries, they often just put themselves out. And that's not the case if you puncture an NMC cell.
Yeah, and a spoiler alert, Nathan, I do have a picture of Will Prowse puncturing a battery cell here coming up, but absolutely, right? If you think about, thank you, Nathan, you think about the batteries that we have in our phones or our laptops, they're small, relatively small, and they're very lightweight, which makes them great for portable. But as we're scaling up these batteries, we're also scaling up the risk. So we need to keep always keep in mind safety. And what I really see in the market is a lot of people are moving towards these LFP chemistries. So if you're looking at somebody's spec sheet, look for those UL listings and look for what chemistry they're using. By using a safer chemistry, we don't have that risk of thermal runaway. We're avoiding some of those toxic elements, which can also be sourced not very sustainably or ethically. We're not totally landfill safe, but I do see a lot of our hazardous waste recycling centers that you have in your local community being better able to take in these batteries. So don't just throw it away, go to the hazardous waste disposal sites. We don't need ventilation or cooling equipment with these batteries. Other people's batteries do need active cooling systems. We're able to avoid some of those safety monitoring equipment because we have proven ourselves in those UL listings, and we can work in some kind of extreme temperatures. So we already talked about this. Chemistry matters, but what also matters is form factor. So we use a cylindrical cell form factor. Think of them as like kind of AA or AAA batteries. And inherent in their design is this metal kind of wrapping around them that kind of will contain any sort of thermal event that does occur. And there's a little vent on the top that allows it to vent out. Pouch cells are prone to puncture, prone to swelling. Prismatic cells, there's not too much wrong with that, but they do tend to have a little bit of a larger cell volume. So when there is a thermal event, you get more gassing, which can be flammable. They also can swell and contract. So cylindrical cells are the safest, although they are the most expensive to manufacture. But if you look at really, you start to account for the safety considerations, lifetime performance, and what we can get when we pack these into a system, we really see that although the upfront price is a little bit higher, we get a better lifetime cost. So really quickly, when a thermal runaway, essentially it's this chemical chain reaction where batteries can spread to other adjacent batteries. And it's not caused by necessarily flaming, but heat. So if you want to, say, extinguish one of these thermal runaway events, the really depriving it of oxygen isn't always going to work. You need to cool the batteries, and that requires a lot of water or something to cool it off. And if you think about the way we construct some of these batteries or energy storage systems, they're usually inside of a case, inside of another metal case, and it's really hard to get at with any sort of water or cooling, somehow able to cool it. So how are these kind of thermal runaways caused? It's usually by circuit failure, by shorting it out, either through abusive batteries such as a car crash, but other things like an unrelated fire, internal short circuit due to a puncture, or overcharging. And part of our 9540A testing is, again, we simulate that. And when we do simulate that, what we've noticed is that it takes a higher temperature for LFP, lithium iron phosphate batteries, to reach that thermal runaway. And then when it does actually reach that thermal runaway event, it has a lower burning, or it has a much lower maximum temperature than some of that cobalt-based. Again, also, and part of it is we have less gassing, and part of that's due to the form factor, but also it's partly due to the chemistry. So there's that picture, Nathan, that I just talked about. If anybody doesn't know who Will Prowse is, he runs a real popular YouTube channel and a forum online. And what he did is, on the left there, you see a NMC pouch cell that he drilled and kind of demonstrated what can happen. Picture on the right is an LFP pouch cell where he's had to drill several times into this pouch cell to even cause it to off gas. Now, Nathan, we looked at this slide a little bit last week, and we had some really good questions about what we're looking at here. And what we're looking, yeah, go ahead, Nathan. I'd like to
take the time to point out, first off, this is research that's been done by the Sandia National Lab Battery Research Center. So this is in outside of Santa Fe, New Mexico, and they have a battery testing lab there where they test for safety and really abuse batteries to make sure that regulations are being done and put in place to keep consumers in the US safe. So what we're looking at on this graph is what this graph tells us. If they took cells and they forced them into thermal runaway, okay? On the horizontal axis, you're looking at temperature. So they force the cells into thermal runaway and get them to off gas. And once those cells are off gassing, that gas that's coming out of the battery cells is electrolyte. It's an organic material that can burn. And so the temperature starts to rise after off-gassing begins. So you can see the LCO batteries, NMC batteries, NCA batteries, LFP batteries. You can see, well, it's really hard to see when the LFP goes into an off-gassing event, but it takes place around 200 Celsius, a little beyond 200 Celsius. And then the other batteries start their off-gassing a little bit earlier. So the first one that you're seeing there go through an off-gassing event is an LCO battery cell. That occurs at somewhere around 180 Celsius. So that's the green curve. After they forced it into thermal runaway, they're looking at a normalized heating rate. So the normalized there has to do with the size of the cell. So they adjust for big cells versus little cells so that you get a fair comparison. And the heating rate means how quickly heat is being released in that off-gassing event, okay? So the LFP cell, you'll notice, is on the very bottom. Again, this is national lab data. You have to zoom in to even see it peak. It's occurring at a higher temperature, so you can use these cells to higher temperatures without having off-gassing occur. And the amount of heat that's coming off of it, if you look at the scale there, it's 1.5 normalized units. When you look at the LCO battery, it tops out around 480 normalized units. So the LCO battery is releasing energy much more quickly, okay? Now, I was talking with somebody who represents a LCO battery company. Actually, I think he represented an NMC battery company. And he was telling me, well, I feel like it's the batteries that are safe. It's not the cells. And I gave him an analogy here where you could take, if you look at the LFP cell, it burns more like a candle. It very slowly releases that heat energy. And you'll see that in Will Prowse's video again as well. That's another independent source. So the LFP would burn kind of like a candle. The NMC battery burns more like a container of propane, much more quickly, right? And that's where the danger can occur. When you release that heat very, very rapidly, you end up with a very quick, almost impossible to put out fire where the fuel source is there and the oxygen source is there. So this it just points out to the safety of LFP. I sincerely believe, and this is not just to sell simplify batteries, I sincerely believe if you're putting any kind of battery pack in your home, you should not put anything other than LFP. Lead acid, yes, but other other lithium type of batteries, they're great for mobile applications where they need to be lightweight. But if you're really looking for safety while you're asleep, don't use any other battery chemistry other than LFP in the house.
Yeah, thank you, Nathan, for breaking this graph down. I know we had a lot of questions about it last week, and it's really a powerful third-party kind of testament to how safe certain chemistries can be over others. And that's exactly right. Part of this course, part of this NABCEP Battery 101 chemistry isn't just to sell products. Of course, we're going to talk a little bit about it, but it's really to help you, the students, people attending this course, to have a better understanding of battery chemistry. And that's part of the mission behind NABCEP. And that's why I'm so proud that we're able to offer these credits as we're doing these talks.
Well, I guess I want to say one other thing about this, Daniel. People will come back and say, well, we have laptops that have, NMC cells in them. We have tools in our garage that have NMC cells. And the answer is, yes, you do. But typically they have 3 cells or maybe 6 cells for a big battery pack. Home-based batteries have hundreds of cells, right? Around, in our typical sized battery, we have around 300 cells, right? And the same for other companies. So we're talking about a much bigger scale. And Daniel pointed that out earlier, right? As you get bigger, right, there's a lot more, that your risk factor increases with the size too. And so that's another point that I want to make. When you're putting a very big battery in your house, it should be an LFP battery pack. And maybe in the future, they're going to come out with other safer chemistries. But right now, LFP's chemistry gives you the most longevity, the most number of cycles, the best warranties. It's a little bit heavier, but it's sitting on a shelf in your house that doesn't really matter. You build a slightly stronger shelf. So
absolutely.
LFP should be the only thing you have in your house for backup.
Yeah, thank you, Nathan. And I should say, LFP is the only one to market. There are a lot of, and I read about these, a lot of other different battery chemistries, but they're still in labs, right? This is something that you can actually go out today and buy and put in your home. And absolutely right. If I think about my Makita tool, right? It's a 5 amp hour battery at 24 volts. That's just hundreds of watt hours, not kilowatt hours and upon kilowatt hours. So it really is a much smaller scale. This is a picture of a home built battery, I believe. And maybe this isn't the talk to do about it, Nathan, but I know you've built a couple batteries and we can talk a little bit about that later. But the point here of this slide is talking about certain cobalt-based chemistries require a cooling and thermal monitoring equipment, whereas our batteries do not. So you're avoiding other modes of failure and other things that can fail with the battery. One thing that holds true for lithium-ion batteries of a lot of different chemistries is that they can't really charge them below freezing. You can discharge them or have them sit idle at kind of a little bit of a wider temperature range. But what we've been able to do is, and we have a couple other talks, environmental considerations in harsh environments, where we kind of really dive into why you can't, what happens inside of a lithium-ion battery when it gets below freezing. We don't have the time in this talk to really dive into that, but it damages the battery. One thing we can do with our amplify and simplify battery lines, those are both leverage closed loop communications to talk to inverters, to talk to different pieces like a charge controller. The battery has these specific amplify and simplify batteries have built-in 10K thermistors, so they know their internal temperatures. So we can actually tell a piece of equipment to slowly start charging start charging that battery when it is in a freezing condition, so we can use the internal resistance of the battery to kind of warm itself up. And so we're able to work in some kind of wider temperature ranges. I see temperature considerations becoming more and more common, especially as we see HJs and inspectors not wanting batteries inside garages anymore, homeowners not wanting the batteries inside their garages, and we start to put these batteries outside in parts of our country that get cold, right? Historically, a lot of our energy storage systems have been in California and Texas and Florida, but as we start to move up into the Northeast and people up there in Minnesota, Montana's, Michigan's, the rate of battery adoptions are starting to grow. We're going to start to see temperature mitigation strategies become more important. Stay tuned to our training calendar where we talk a little bit more about this. Point being is that if you are going to be working in a kind of more of extreme temperature environment, consider leveraging our Amplify battery and our Simplify 4.98 battery in these cold weather applications. We also have the ability to add battery warmers. You got to let us know ahead of time for something like that, but we can definitely work with you and get you something that's going to work in extreme colds. I think I did see a touch on this is we have a 10-year warranty, 100% depth of discharge at an unlimited cycle, right? So a lot of other people's warranties might say a certain depth of discharge, a certain number of cycles, or maybe even a certain amount of megawatt hour throughputs where we're only warranty it for so much energy in and so much energy out. What we want to do is keep it simple, 10 years. That being said, I would like to see more of an 80% depth of discharge on your system so that you're going to get the most life out of the battery after its warranty period. If you do choose to cycle it down to 100% DOD every time, at the end of the warranted battery life, we still warranty for an 80% retained energy capacity in that battery. All of our batteries, I should say really all lithium-ion batteries, have a built-in battery management system. They're mainly there for cell balancing, but some of the battery management systems can kind of act as a lifeguard to the battery. So it has the ability to disconnect itself from the other components if it sees situations it doesn't like. Perhaps it's being overcharged, over discharged. If it's short circuit, it can go ahead and open up. We have 3 battery management systems. We have in our standard Phi battery, a analog only non-communicating battery management system. In our Amplify or Simplify batteries, we have a digital communicating, closed loop communicating battery management system that still does all those same features, but can also transmit information to a piece of equipment. The third type of battery management system is found in our high voltage solutions, and it's called a stack controller. And I got a picture of that coming up here in a second. One of the key features of our batteries is the ability to charge and discharge the battery relatively quickly. And I believe that holds true to lithium-ion batteries in general when compared to lead-acid batteries. We have a C/2 charge rate, which means that you can charge or discharge one of our batteries in 2 hours. What that means is that you can say if you have a generator running and you want to charge up that battery quickly, that battery bank, you can run the generator at kind of a full tilt, get that battery charged up and then shut it down. Maybe you don't have a generator and you got solar and you have a kind of a small solar window to charge up the batteries. You can really charge that battery up quickly. What it also means is that if you ever come out and do a lead acid battery replacement, you can replace the batteries, those lead acid batteries, which typically have more of a C/20 discharge rate or a C/10. If you're really hammering on them, a C/5, you don't need as many batteries in the bank to handle that power requirement. Another key feature is that we can scale these batteries up. We scale in increments of 3.8 kilowatt hours or 4.98. That means they're kind of, think of them as kind of like building blocks where you can use them kind of as Legos, I guess I will say, to scale up to the size system you need. Picture on the left there is an airport hangar in Hawaii, where we've scaled up 80 of our batteries to get up to 300 kilowatt hours. I really like that picture because of all those cool copper bus bars you see. We always want to wire our batteries in parallel, never series, and that's what you're seeing there. Picture on the right is an example of how we can expand. And I always like to have that conversation with the homeowner when I'm sitting down at the kitchen table. Perhaps they don't have the money to buy the largest system at the time, or perhaps they aren't planning, they can plan for the future. We can go in, install a system, and let the homeowner know, or business owner, that we can come back and expand that system later and add batteries. And that's exactly what you see here on the picture of the right. We kept that existing SMA Sunny Island there, kept that existing combiner, and we were able to add 8 more batteries. We doubled the battery bank size on that system. LFP batteries don't vent like our good lead acid battery days, right? There's not that hydrogen gas, so there's none of those vent fans. We also don't need to water the batteries. Anytime you sell a lead acid battery bank to a homeowner and you get a call, that the system's down, well, did you water the batteries? Did you maintain the batteries? That's not something you're going to have to worry about with sealed lead acid batteries or a sealed batteries like you'd find in lithium-ion chemistries. Lithium-ion chemistries also have a much lower self-discharge rate. I think about this in kind of those winter cabins or the summer cabins, I guess you would say, in the Northeast and then in the North, where you have these cabins, lake cabins, that just kind of sit there in the winter. You could have a system turned off, the batteries will sit there, and you can turn the breakers off to the batteries, and they'll have, a 1% self-discharge per month. So when you do come back in summer or in spring, and it's time to recommission the system, the batteries are going to have enough juice in them to get the charge controllers to come alive, get the inverters to come alive. And of course, make sure you get a good full bulk charge on those batteries before you start turning the loads on the next day. But the point being is that these batteries don't have that same self-discharge rate that you'd see with, say, your truck battery or your car battery. Lead acid battery replacements has really been something that Simplified Power is kind of cut their teeth on. We've always historically been able to go in. I mean, what a mess on the left there. What are those Trojan L16s? They look like 6-volt batteries, a bunch of battery cables going everywhere, that electrolyte pastes. We're able to pull those batteries out and replace it with a much cleaner, much smaller system that has just as much energy capacity and just as much ability to provide power, the C rate. We're going to jump through some of our products really quickly. I know we're running a little short on time. I want to be respectful of everybody's time here. Our Phi 3.8, this is a 12-volt, 24-volt battery that does not have closed-loop communication capabilities. That doesn't make it not as good as the batteries that do have closed-loop communication capabilities, because a lot of pieces of equipment that are still out there, like old magnesigns and old trace products and stuff, can't leverage closed-loop communications. So why would you buy a battery that has that capability that can't participate in that communications? You're kind of spending extra money for naught. So we do still offer these 3.8s and 24 and 48 volt options. It still does have that integrated battery management system. If you do have a piece of equipment that can listen, go ahead and leverage the Amplify battery that can talk. It has the ability to auto-populate set points. It can transmit its state of charge very accurately, and its temperature, like we talked about earlier, to protect itself. One thing is that I'm still seeing out in the market is 12-volt systems. And it's hard to believe that 12-volt systems still exist, but they do. If you do have a 12-volt system, maybe put it in the Q&A. Let us know what the smallest system you've ever installed is. I think that would be fun to call out. The smallest system, what, a couple hundred watts of solar. a PWM charge controller, and you got a 12-volt battery. These are great for mobile applications. They're kind of smaller and can fit into kind of smaller installations. One thing that we do still offer are kind of portable systems. And one thing that I'm kind of mindful of is there's a whole market potential out there for people that rent homes, people that live in apartments, people that live in mobile situations, and they still want to be part of this energy, revolution. They still want to be able to leverage energy security, and they can't install something permanent. Well, that's where something like this comes in, the Express system. This is a portable system that still has this outdoor rated enclosure. You can just simply plug this system into the wall, and it's going to use grid electricity to kind of float those batteries. That Magna sign right there is just going to keep these batteries topped off. Whenever there's an outage, the Express system has an outlet, right? So you can plug in your other components. Yeah, you're going to have kind of extension cords a little bit, but this also has a charge controller. So you still can leverage a small solar array, and has a DC kind of inlet that allows you to charge up these batteries. So if you haven't seen these systems before, it's definitely exciting to see systems for people that rent. For more permanently mounted systems, we have our Access system. It's just like that Boss 12 cabinet that I showed you before, but we can put a industry-leading inverter up top. In this example, we have a Solar. I think that's a Solar 12K there, but we can also put in our own inverter. It's great because you can go out and put this outside right next to an existing grid-tied inverter, like a Fronius or something, an AC couple in storage. Or maybe you're coming down from a combiner box on an in-phase system. Those are the Boss 12 cabinets you see in the middle, but we also have a Boss 6 cabinet that's a little bit smaller. It's half the size. That can still leverage the outdoor rated. One thing to keep in mind is everybody is moving towards vertically integrated energy storage systems. It makes sense. They're all pieces and parts that have been vetted to work together. One warranty, one tech support, one easy commissioning of the system. There's three parts of all these energy storage systems, right? There's the inverter, there's a battery, and there's an app. And one thing that is really cool about our inverter is that it's called a hybrid inverter. So it's still able to AC couple, but it has built-in MPPT charge controller, so you can DC couple. It also has an extra AC input, so we can go ahead and that we would usually use to AC couple, but if we have a situation where we want to charge the system with a generator, we can also do that. 8 millisecond transfer time, so most people don't even see their lights flicker. They don't even know the power is out unless they open up their shades and look across the street and see that their neighbor's out of power. This battery here is outdoor rated, unlike the 3.8s. But just like the 3.8s, this 4.98 battery still has the same chemistry, LFP, still has the same form factor, cylindrical, and still has the same battery management system and breaker that the other Phi 3.8 and actually has the Amplify 3.8 closed loop communication battery management systems. So it still has that same warranty. The only thing, it's kind of repackaged in this outdoor package. The app, this is something I don't want to just skip over. The app is very powerful. The app is something that people look at, right? Homeowners don't go out to the power shack anymore and look at the voltage on their Victron battery management system. Well, yeah, a lot of those Victron battery management systems have their own app too. What do people do? They get their phone out and they look at these little graphs, and they can see where power is flowing. These apps allow people to adjust the parameters. So say they know a storm is coming in, they can put the system into a storm watch mode. Installers love a good app because it allows for easy commissioning, easy remote reconfiguration. What does that mean? It means maybe you didn't get the settings exactly right and you're driving back to your shop and you realize that. Well, you don't have to turn around. You can just go ahead and get your app out. You as the installer have a an installer permissions, whereas the homeowner has got the homeowner's permissions. This is pretty common the way people set these up. So a lot of energy, a lot of money, a lot of people's time, really smart people's time went into developing this app, and it's kind of that third leg of the stool. I said this earlier, but I really want to focus on the high voltage for commercial situations. If you're somebody on this call that's working in these commercial systems, reach out to us, let us know. We have an entire team of application engineers that are really knowledgeable about our commercial high voltage solutions. Yeah, you see pictures of big containers there, right? That's a 40-foot container. We got 20-foot containers, but we also have rack mounted solutions, and we can make them work in the voltages that you need, and we can scale them up. These are the server rack applications that you see there. These rack mounted solutions are 4.3 kilowatt hours each. They have that same cylindrical cell, same chemistry, and that same C/2 discharge rate. This is a picture I wanted to show you here because this is showing the stack controller. So you can see, unlike our Phi and Amplify and Simplify batteries that are all designed to be wired in parallel, the high voltage solutions, hence the name high voltage, are all wired in series, but they're still made up of 24 or 48 volt building blocks. So you can see how these are all wired in series. And then up top, we have our battery management system. The 20-foot solution, can or cannot be equipped with all of the other inverters and cooling systems that you may need, and the 40-foot solution as well. Reach out to us and we work with you on these systems. We're finishing up. I know we just got 4 minutes left here, and I want to make sure we leave time for questions. Always don't just look at the upfront price of a battery. I would argue don't look at the upfront price of anything you buy in this world. Always look at what the lifetime cost or what the lifetime price or cost of a system is going to be, right? So if you look at an Amplify or a Simplify battery, it's going to cost more than, say, a lead acid battery. But if you start to account for the ability for that battery to have more cycle life, more efficient round trip, the ability to discharge it further and its capacity, you start to realize that for every kilowatt hour I put into this system and take out of this system, the lifetime cost is truly less. And you can even make that comparison with other lithium-ion batteries. And that's not even accounting for ancillary costs like cooling systems or maintenance, like watering the batteries or other kind of specific installation equipments you might need. Don't have to do the math. We do have a calculator on our website to handle that. We talked about this earlier, but there's the ability to have battery capacity, right? That's energy capacity. And then there's the amount of ability for a battery to provide power at any one moment. That's the C rate. And again, let's just give an example, a 20 amp hour battery, for example, it can discharge at 10 amps over the course of 2 hours. That would be the C/2 discharge rate. When we're talking about sizing, I talked about this a little bit earlier, I'd like to see you size for an 80% depth of discharge. That's going to give you about 10,000 cycles on our batteries. And if you're discharging it daily, right, 10,000 divided by 365 is about 27 years or so. Do I think one of our batteries is going to last 27 years? I hope so. But the point being is the shallower you cycle the battery, the more cycles you're going to get out of it. But it's not like a lead acid battery where we only can go 50%. Really, if you got a situation where you're not discharging the battery regularly, or maybe the battery is even just sitting there, go ahead and size that system for a 90 or 100% depth of discharge. You don't have to add a couple batteries to the system just to make sure you're only getting to that 20% depth of discharge. My example here is that 8,000 watt Radian right there. Each one of these batteries is 3.8 kilowatt hours. I just said, they can only discharge at C/2. So 3.8 divided by 2 is 1.9. So each one of these batteries that you see in that picture has a max charge or discharge capability of 1,900 watts. So if I have an 8,000 watt Radian divided by 1,900, I get about 4.2. So that means I need about 5 of these batteries so that if ever that radian starts discharging 8,000 watts to load, you're not going to exceed the maximum continuous discharge capability of the batteries. Of course, they can surge, but in this example, you can see there's much more than 5 batteries. They had to increase the battery bank size for the autonomy reasons. We have a lot of calculators available that help you size out systems. And we also have the ability to do some electrical load. Sizing these energy storage systems, especially for grid-tied interactive systems, is complicated. A lot of people want to size to the backed up loads, but really we should be sizing to what we expect time of use arbitrage to be. Or if we're in a net metering situations, we're thinking about sizing to that component, not necessarily sizing to what somebody is going to expect for an outage. We do have a lot of installation manuals, spec sheets. What's really cool are integration guides. These are guides that we spent a lot of time helping people that are taking batteries, integrating them with other people's equipments like Schneider, like Magnuson, like Victron. Well, these integration guides tell you how to program those other pieces of equipment, usually in the order in which they're asking for those programming. And that allows you to make sure those other pieces of equipment are treating our batteries the way they want to be treated, and you're not voiding your warranty. When you do get your battery, please make sure you check it for damage, and also keep your packaging in case you ever have to send it back. And make sure that when you do get the your multimeter out and you're testing the battery voltage, that when you see a battery at a certain voltage out of the box, keep in mind that that may not always be it's probably not a fully charged battery. Part of the DOT requirements is that we don't ship these batteries at a full charge. So you're going to expect to read a voltage and you may think, oh, it's at 52 volts or 51 volts. That's not true. That's not a fully charged battery. Let's be sure you get it onto a full charge cycle. We do have upcoming trainings. That's discharge training, where we're going to go a lot deeper into what we expect a fully charged battery at resting voltage to see. You can install these batteries on the wall. You can put them on the sides. You just can't stack them or put them upside down. We talked about this. We always want you to wire our batteries in parallel, never in series. And when you do wire them in parallel, in most situations, I'm going to want you to use conductors of the same gauge, of the same length, go into a common connection point, like a bus bar or a terminal block. That's going to ensure that each battery is working just as hard as the next. An example here would be this Midnight Solar combiner here. But there's bus bars, and there's also terminal blocks that I've seen used. Always please get out your torque wrench. I'd like to see 160 inch-pounds on the battery terminals. Don't use an impact driver. Ideally, you'd want to see an insulated torque wrench, which is you see up there at the top. And the one at the bottom is uninsulated and non-digital. Here's a couple examples of what it can look like. What do we got here? We got a solar. We got some DC coupled solar. These look like microinverters. They're not. They're Tigos, because here's a Tigo transmitter. We're feeding DC into the solar. The solar is feeding DC right out through those MPPT charge controllers and keeping these battery banks properly charged. Here's where we're combining the battery banks. Here's our critical loads panel. Here's our non-backed up loads panel. And here is grid. Kind of a bread and butter system. This could be an off-grid system. You would just simply get rid of this grid and this non-backed up loads, and we would just simply have all loads backed up. I said it before, our batteries can be paired with lots of other people's equipments. This is an example of an AC coupled system. We got a Schneider XW here. Same situation, a couple of Boss 12 batteries. In this example, AC coupled, right? These are IQ 7 pluses, they look like to me. This could probably be an IQ combiner right here. Backed up loads, non-backed up loads. Here's an example of utilizing a generator in a system. This is something I'm really excited to develop a new talk about and talk to you all about this. Just like that first example, we have DC coupled solar. In this example, they're AP smart systems. We're charging the battery we're charging batteries direct DC. Only when we need to discharge the batteries are we turning it into AC. We can power home loads, backed up loads. Also here would be non-backed up loads, and here's grid. The generator can be started and stopped based on what the inverter sees. The inverter has a 2-wire signal to start. We can signal the generator to start usually on 2 kind of factors. One, if the state of charge of the batteries is getting too low, we can charge, and it's cloudy out, it's nighttime, we can use the generator to charge up that battery bank and then shut the generator off. We could also use the generator to help support large loads that are on that the inverter couldn't otherwise handle. Finishing up here, thanks guys sticking with me. I'm going a little bit over time, but we do have that Power Academy I promised we would talk about. Get your phone out. There's a UR code to go to the Power Academy. You can sign up at the Power Academy to do in-person trainings, like live in-person trainings. We do them around the country. We have a trailer that we tow around with our generators, with our energy storage systems. We can do live virtual and also self-paced, pre-recorded e-learning. So if you're somebody that doesn't have time at certain during the day, you can do these at night or when you do have a break. Anybody can sign up. You don't necessarily have to be a dealer or distributor. If you are somebody that's just wanting to learn more, you can go ahead and click the rep group and go ahead and put in your business name to get authorized to get into that. If anybody has trouble doing this, let me know. My email's coming up here in the next slide or two, and I'll help you get signed up. We also do have an opportunity for anybody that's out there installing energy storage systems to become one of our IQ installers, and we can put you on our maps. You can be eligible to get some cash back. Also, we have a photo contest where we're giving out $250 for a great looking install photo. I always like to install photos that show, the people, whether they're the installers or the homeowners. But really, part of the program is driving people looking for our products to qualified installers like yourself. This is the QR code to join the installer program. There's the email, training@simplifypower.com. If you're looking for your NABCEP credits, please email training@simplifypower.com. If you're looking to get signed up for the Power Academy, please go ahead and send me an email. Nathan, that was, we kind of ran out of time. We're going pretty quick at the end. Is there any questions we have?
Sorry, I was struggling to unmute myself there, Daniel. Yes, we do have some good questions in the Q&A. Could you touch again on the amount of cycles and the depth of discharge that these batteries can handle? And this was an anonymous one, and I'm going to go ahead and answer it here. So if you do a depth of discharge and you limit to 80%, so depth of discharge limited to 80%, so you leave 20% of the energy in that battery on each cycle. We expect you to get 10,000 cycles, and we warranty it no matter what for 10 years, right? But we expect you to get 10,000 cycles, cycling once daily, you're looking at, about 27 years. If you do a depth of discharge to 90%, it greatly reduces the number of cycles out of the battery down to about 6,000 cycles. So 90% depth of discharge, we expect you to get only about 60% of that, the number of cycles. Still, 6,000 cycles, you're still looking at something like 18 years. And if you do a depth of discharge of 100% every single cycle, right? We only expect you to get around 3,000 cycles or about 10 years out of the battery if you do it 100%. Now, we realize that people will use a combination of these, but that gives you a pretty good idea. And these are some of the best numbers in the industry. We use premium battery cells to make our batteries. We use top of the line, made in the US, BMS systems. These are designed in California, and we've got really good BMS systems. in our batteries, and we expect really good comparable lifetimes out of these batteries. So that was one of the good questions. Anton Miller mentions Grid Alternatives as a great nonprofit. Anton, I've done installs with Grid Alternatives, and we work with Grid Alternatives, and I agree, I highly recommend them. So if there's a specific project you would like to recommend, let us know. Venkata asks, Daniel, will the BOSS 12 unit accommodate the SolarArc 12K inverter as well?
Yes, it will. It will accommodate the SolarArc 12K, and that's something that we offer prepackaged. A lot of the BOSS 12 or the system, it's the access system, the SolarArc 12K will come pre-programmed, but always encourage you to double check some of those settings just in case anything got reset when it shows up at your door.
And I saw one of those 12Ks yesterday in an access cabinet, 6 batteries there and an additional 12 batteries outside of it. Yes, they do accommodate the SolarArc 12K. And if you're looking for an EMP hardened 12K, we also can offer that to our customers, though that one's a special order. Senyo asks, are there available capacity versus temperature charts you can share? We do share those out as part of our charge and discharge training, Senyo. And so you'll get those slides if you sign up for that training. And if you need that sooner, go ahead and send us an email. Daniel's mentioned the email right on your screen in front of you. And then there's a question from Senyo as well about any DC generator case studies that we can share. And to our knowledge, Briggs has not developed a DC generator yet. I cannot tell you whether or not one's in the works. We certainly have a full lineup of generators, but we don't have any case studies with DC generators yet. And then the last question here, we've got one from James Rossell. And James asked, if you have a 15K SolarArc off-grid system, you can use the utility port for a 62 amp load and the critical load panel for a 50 amp load. I think that was just a statement in response to something you had said earlier.
Yeah, absolutely. When I was showing that diagram, we wouldn't utilize the load out port for an off-grid system. We would simply utilize the grid port for an off-grid situation. Absolutely. Good point.
Thanks, James. And thank you all. I appreciate you attending our training today. Thanks for bearing with us as we went a bit over time. Please, if you're here for your NABCEP credits, send an email to us at training@simplifypower, and we'll get those certificates issued. Make sure to include how you'd like your name spelled on the certificate. So thank you so much.
Yeah, thank you, Nathan. And thank you, everybody. We'll see you guys next time. Next week is the new training from Nathan. And we'll look forward to seeing you guys there.